You know I talked about there's different things when you see things, you have to do things, right? So when you have a numerical base to a variable exponent, you need to realize that that is a numerical base to a variable exponent. Rewrite it, ln the base, derivative of the exponent, right? Told you when you get a trig, you have to realize that if it's a squared or a cubed, you would write that outside and do chain rule, right? There's all these different things that you have to spot. You have to see if it's a ln, you have to realize that you have to rewrite in the bottom, ln the base. So if it's log anything that's not base e, you're going to end up with a ln in your denominator. And then a numerical derivative. Not numerical derivative, a derivative in the numerator. So logarithmic differentiation, you spot when it looks a little crazy. When it looks like you might have a product rule, quotient rule. That's one of them. So there's two styles where we're going to use logarithmic differentiation for. The first one is when you have a product rule, quotient rule. And you think, wow, this is terrible. Because you don't do it as a product rule, quotient rule. You do it as logarithmic differentiation. So it's like a product rule embedded in a quotient rule. And you're like, man, f of x is going to be, or f prime is going to be awful. Yeah, it will, because you're not supposed to do it that way, right? Also, do logarithmic differentiation when it says, determine the derivative of this using logarithmic differentiation. It's a dead giveaway sometimes. Okay, so our first example is going to be determine y prime when y equals 2x minus 1 cubed 4x plus 3 squared over 2x plus 5. So like your f prime would be a product rule, but this whole thing is actually fg, which is a quotient rule, right? You can kind of spot it. There are steps that we will do every single time we see this. This first step will bring joy to Peter's heart. Step 1, log both sides. You write log in front of both sides. Base 10. We're using log base 10. We're just writing log. Okay. So we're going to go log. Well, you know what? I want to use natural log because if I use...
Sorry, that's just what I said. That was crazy.
Really?
Yeah, I said ln is shorter in the calculator.
And ln is also shorter in the fact that I don't have to, if I do the derivative of it, I don't have to put a ln in the denominator.
Yeah, also one less letter. Sure.
Also one less letter, which is the selling feature. Okay. Ln y equals ln 2x minus 1 cubed 4x plus 3 squared 2x plus 5 to the half. Oh my gosh, why? All this for not having the weather show up. Not worth it. Oh my god. I feel like, oh, it's just...
We're not gonna know what's happening.
Okay. So we log both sides. So in this case, it would be ln, Vaughn put it away. Now, 2, we use log rules. Which log rules do we use? Product to quote product? No. Quotient. And I don't mean product and quotient of derivatives. I mean product and quotient of, like you could do product and quotient of logs. So remember, over here on your formula sheet, if we have logs that are multiplied together, we can separate them by addition signs. And if we have logs that are divided, we can separate it by a subtraction sign. Remember when I taught it, I just said, if it's in the numerator, it gets a +1 in front. If it's in the denominator, it gets a -1 in front. Correct? So if you remember that step, everyone will get the rest of the question right. But all we have to do first is we ln both sides, Then we actually expand this side. That side there's nothing to expand. This side we're going to expand to plus and minuses. So we're going to get ln y equals ln 2x minus 1 cubed plus ln 4x plus 3 squared minus ln 2x plus 5 and a half. What did we do next when we did all the solving? What did we do next? Remember? Drop the exponent. So step 3 is going to be using power rule. See, these are the same problem. They're called power rule of logs. So power rule of logs causes to drop in front. If you don't drop it in front, you can still do it, but you're going to have to do like a chain rule-ish deal in your numerator when you do the derivative of a ln, which is way more terrible. So we're going to go ln y equals 3 ln 2x minus 1 plus 2 ln 4x plus 3 minus 1 half ln 2x plus 5. Now it's in a format that's easier to do derivatives with. So differentiate. So what's the derivative of ln y? Well, the derivative of any ln, you take what's on the beside the ln goes in the denominator. The derivative of y on the top. The derivative of y is just 1, but then dy over dx. We'll undo this in a second. And then equals 3 times, be 3 over 1 technically, times the derivative of ln 2x minus 1. Remember, if there's a coefficient, you can just write it. I've said that a whole bunch of times. I don't know what I was going with the that's it. I was stuck there for a second. I told you that a whole bunch of times. So the derivative of ln 2x minus 1, take the 2x minus 1 in the denominator. The derivative of 2x minus 1 is 2. Plus 2 over 1. You see, if you forget to drop the exponent, you're going to actually have to do the derivative of 4x plus 3 squared on the top, and then cancel stuff off. It's kind of terrible. So always distribute it in front. Okay, so here we get 4x plus 3 in the denominator, and the derivative of 4x plus 3 is 4 in the numerator. Minus 1 half. The denominator is 2x plus 5, and the numerator has 2. And we put them together. Now, ultimately, in the end, I want dy over dx, true statement, by itself. How do I get rid of a division of y? So I'm going to multiply this whole side by y. So I'm going to get 6 over 2x minus 1. And then here I'm going to get 8 over 4x plus 3. And then I'm going to get minus 2 over 2 times 2x plus 5. And then my last step is to substitute in the y. It doesn't get any better than that. So you can't just leave the y there, you have to substitute in your y. And people are like, well, where do I get what y equals? Where's your y equals? The very question. So my y equals is this. So I'm actually going to put this in for the y. So I'm going to go dy over dx, and then I'm going to put an ugly fraction in front. The ugly fraction that was in front was 2x minus 1 cubed, 4x plus 3 squared, and then 2x plus 5 to the half. And then I just rewrite this big box fraction beside, and they don't make you do common denominators or anything, which is nice. And that's it. So pretty, isn't it? So this is your answer.
You can cancel the twos.
Sure. I'm not rewriting.
Wait, sorry, say that. Why did you get rid of the letter?
Totally different computer. So I said I did a different computer, but now I have this box thing going off all the whole time. I don't know if it's worth it.
It's not.
Yeah. She brings back the letter.
I meant
Sarah, try again. Get me out of the picture.
I don't know what's going on outside.
I just stood in front of half the board.
I see. Yeah, we got
Can't open your eyes.
surrender.
All right. You guys are going to try this one.
It feels like
Example 2. I don't know why I didn't capitalize that. Anyways, determine y prime. Technically, the last one I said determine y prime, correct?
Yeah.
So we should have wrote this instead as a y prime at the end, because we have to actually set it equal to what it says, right? Okay, so here we're going to determine y prime if y equals x squared times the square root of 5x plus 1. What are we going to have to rewrite that as?
It's 1 1/2.
5x plus 1 to the power of 1/2. And then in the bottom, 3x minus 2 cubed. Try that one out. So, we would have ln of y equals ln of that. Change that to a half. Then we expand it using our product and quotient rule from grade 12. So we get ln x squared plus ln 5x plus 1 to the half minus ln 3x minus 2 cubed. Take our exponents, drop them in front. So we get ln y equals 2 ln x plus 1/2 ln 5x plus 1 minus 3 ln 3x minus 2. All right, then we have to do the derivative of each. What's the derivative of ln y?
I dy over
X over
x
Y.
over 1.
And if we don't want to write dy over dx, what could we write?
Y prime.
Y prime. So we would get 2 over 1, derivative of ln x, x on the bottom, derivative of x is 1 on the top, plus ln e on the bottom, but we don't have to write it because ln e is just 1. Now this one is a half, 5x plus 1 in the denominator. What's the derivative of 5x plus 1? 5 minus 3 over 1. 3x minus 1 minus 2 in the denominator. Derivative of 3x minus 2 is?
No, sorry, 3.
3. And then that becomes 9. Yep. So we get y prime. Y comes up here because we multiply both sides by y technically. And so we get y, and then we get 2 over x plus 5 over 2 times 5x plus 1 minus 9 over 3x minus 2. And then we have to fill back in our y. So we get y prime equals x squared square root 5x plus 1 over 3x minus 2 cubed, square bracket, 2 over x Go away. Don't like you. Why? I want to go.
Yes.
Stay over there. Will exist over there. Plus 5 over 2, 5x plus 1. Ah! Weather's worth it, I'm telling you. I have now decided. It is, except you guys sidetrack, like when you throw, if I put a feather in this room, you'd all be done. It's a feather floating. Why is there a feather floating? Guys, I'm teaching logarithm feather. It's kind of whitish. I wonder what the mass is of the feather floating. I wonder if it's the increasing of the gravity and then the surface area of the feather. Look,
But Miss Lepp, how can everyone see off of Vaughn's phone at the front of the room?
Yeah.
Oh my God! It went up to minus 14.
Yeah, it went up. It went down. Yeah.
yeah,
How am I supposed to know what the wind gusts are going to be now?
I don't
It was
know.
11 kilometers per hour when I last looked, and now it might be different.
Your second type of logarithmic differentiation
That was weird.
is when we've talked about when you had a variable base to a numerical exponent, we just did power rule, so that's like x squared. We talked about when we had a numerical base to a variable exponent, we'd rewrite it ln the base derivative of the exponent. What we have not talked about is if we have a numeric or a variable base and a variable exponent. So number 2, the second time you use logarithmic differentiation is when you have a variable base and a variable exponent.
Are you good?
Survive. I can't even. Example 3. Determine dy over dx if y equals x to the x4 plus 3x. Oh, my goodness. Yeah. Whoa. So so logarithmic differentiation literally just means I ln both sides to get something to work. Okay? Then we do math to finish out the rest of it. So I'm going to ln both sides. So I'm going to get ln of y equals ln x to the 4 plus 3x. So I still, step 1, ln both sides. Step 2 is still the same. Bring down. How else are you going to do it?
Yeah, come on, Peter.
Bring down the exponent. So we're going to get ln of y. Bring this up here so I'm standing in front of it. Ln. Ugh. Thanks, board. Ln of y equals x to the 4 plus 3x ln x. Now, if I gave you this question, could you do it? No, the other one's a numerical base to a variable exponent.
But you end up with like pretty much the same pattern.
No. How are we going to solve this one?
No.
No. Because we haven't done the derivative yet. All we've done is just literally taken the ln of both sides. There's no differentiation yet. So now we have to derive both sides, correct? This is a product rule. Differentiate. So it's done different than the other one because we have a product rule. The last one we kept lns on each one and then we did the derivative of ln. This one we actually just do the product rule to the left hand side or the right hand side. So we want dy over dx. So the derivative of ln y is y in the denominator, dy over dx in the numerator. And then this I have to do product rule. This is f, this is g. So g is ln x times f prime is 4x cubed plus 3 plus f times g prime, which is 1 over x. which actually works out nice. Why does that work out nice? It would be like this now, correct? What could we do? Take out an x out of every term. It has to come out of all of them, or it can't come out at all. So this x would cancel, this x would cancel, this would become a 3. So this is going to end up actually being x to the 3 plus 3. And then this just stays there. Multiplied by our y. Not sure why I'm writing these on a slant. And then I would get dy over dx equals x to the x4 plus 3x
Oh.
times ln x.
Right one X. You do two separate. Because I end up just doing.
Just so you know, these aren't as noticeable that it's logarithmic differentiation. So if I give you this, okay, like cos x to the sine x, people don't spot that that's a logarithmic differentiation question, but it's an x to an x. So it 100% is the same as this last one. Just the signs are close to the front of it. So watch yourself. This is still the same as that one. You have a variable base, variable exponent. You have to do logarithm. So your questions are going to be 53, 55, 63 to 69 odd.
Oh no, that wasn't you, Sandy.